Hello everyone and welcome back. Today we have 80, remove duplicates from sorted array 2. And here we are given an integer array nums sorted in non-decreasing order. So nums is sorted, and from here we are to remove duplicates in place such that each unique element appears at most twice. Each unique element can appear at most twice. The relative order of the elements should be kept the same. Now, there is a challenge at the bottom. It says to not allocate extra space and to solve this with constant extra memory. So we can try two approaches. Really, the most intuitive approach was the one where we do use extra memory. It's a quick solution, so let's go over it quickly. Basically, we're holding some mapping of the counts where the key is the number and the value is its count, right? And then we always keep track of the insert point. We can start from the beginning. And then for num in nums, we first add to our counts of that number, 1 plus whatever is the current count. And if there is no current count, we can initialize it to 0. Then only if the count of that number is less than or equal to 2, since each unique element appears at most twice, only if this condition holds true, then only we update in place nums at the next insert position to be whatever is the current num. Okay, and then of course increment our next insert position. And at this point, I will point to not only the next insert position, but ultimately the total number of unique elements where each unique element can appear at most twice. Then we can return I directly. And yes, this does work. Yes, and the time is linear. However, space is also O of n, but our target is O of 1. So in order to achieve this, let's use the fact that we know that each element can appear exactly once or twice, right? So can we use that to our advantage? And it turns out we can. Let's take the example number 2 out. Well, first of all, we know if a number can appear at most twice, then couldn't we just ignore the first two? There's no way the first two could ever be disqualified because a number may appear once or it may appear twice. So the first two, whatever the numbers end up being, will be okay. So then, ignoring the first two, we can start at index 2, which is the third value, and say, all right, then does my current value duplicate the value which is 2 spaces before me? Does this value duplicate 1, 2 spaces before me? It does not. So I can stay as is. So I can remain a 1, right? The first two can certainly remain as is. And then we're checking this guy. All right, this is the next insert position. Next insert position. And we'll say, do I duplicate the value, which is 2 spaces before the insert position? The insert position is currently here, and 2 spaces before that is a 0, which this does not duplicate. So we can add that, great. And then we can move the insert position here. This might get confusing. Let's say that the insert position is being tracked with this instead, okay? This is the insert position, and this is our iterating pointer. Okay, now we're here. And does this value duplicate the value which is 2 spaces before the next insert position? And in this case, it does. So we can ignore this guy. right? We can ignore this, and this space is still empty, still yet to be filled, and we move on. Now we're at 1 again, and 1 does duplicate the spaces, 2 spaces before the next insert position. So we move on. So this is still yet to be filled. And now we're at 2 finally, and this value no longer duplicates the value, which is 2 spaces prior to the next insert position at index 4. So we can finally add this value here. Okay, and finally the next insert position becomes 5. All right, and then we're at 3 for the next one. Does 3 duplicate the value, which is 2 spaces before the next insert position? Does this duplicate the value here? It does not. So we can add its value here. And once we do that, make sure to increment the insert position. Okay? And we move on. And here we have another 3. Okay, and where's our next insert position? Our next insert position is at index 6. 2 spaces before that is index 4, which currently holds 2, which certainly does not duplicate here. So yes, it qualifies. We can add a 3. And at this point, we hold total 7 elements. Our next index position is a 7, but we're at the end, and we hold total 7 elements, and that is exactly what we return. Okay, so let's translate what we did here into code using the constant extra memory. We can do it now. So let's reset that, confirm, and what did we do? We were starting from the third one. Okay, we're always tracking the next insert position, which is 0, 1, 2. 0, 1, 2. Yeah, that's the third one. And then we're saying for num in nums 0, 1, 2. We're starting from the third one, and we're saying if whatever current number we're on does not duplicate whatever is 2 spaces prior to the next insert point. So as long as this doesn't duplicate whatever is at nums of I minus 2, then we can say, great, you're not duplicating for the third time, and we can update the next insert point with whatever is the current number. And once we do that, we use up this insert position, so make sure to increment the insert position. And once we do that, believe it or not, this is pretty much it. And we go through starting from the third number and check whenever the number that we're currently on does not duplicate whatever's 2 spaces before or previous to the next insert position, we can safely insert our current number, increment the next insert position, and at the end, we'll be at the position following the non-duplicated numbers. And then submit. And there you have it. This is time or then linear and space constant. And we satisfy this, and there we have it. Once again, this is 80. Remove duplicates from sorted array number 2. And happy coding. See you next time.